Okay, this is example 72, section 4.7 here in calculus. We're looking at antiderivatives. And so we just went over in example 71 different formulas. So we're going to talk about those formulas to be able to find antiderivatives for each of these following functions. So in part A, we have little f of x equals x to the fifth. So we want all the antiderivatives, or the general antiderivative means all the antiderivatives. All that means is add your plus c when you're done, of x to the fifth. So we're going to use the power rule, which says add 1 to the exponent, so that makes it x to the sixth, and then divide by that number. And then it's easy to check, right? That's the nice thing about antiderivatives. You just check, take their derivative, and see if you get back to where you want it to be. So the derivative of x to the sixth is 6x to the fifth. The sixes cancel, and you end up with x to the fifth. The derivative of c is 0. All right, so this is g of x equals the square root of x. So now that's the same thing as x to the 1/2 power. So we can use our power rule. X to the 1/2 plus 1 is 3/2. Divided by 3/2 is the same thing as multiplying by 2/3. So it's 2/3 x to the 3/2. Don't forget to add your plus c. And if you take its derivative, you quickly see it is x to the 1/2, which is what we wanted when we started. All right. Little h of x is sine of 2x. So what function, if I take its derivative, gives me sine? Well, that's going to be minus cosine of 2x. But then I have to divide by the coefficient of x here. So it's minus 1/2 cosine of 2x. Add your plus c. And then if I take its derivative to check, derivative of cosine is minus sine, so minus a minus sine of 2x times the derivative of 2x is 2. Makes those 2's cancel, and you're good to go. Same with cosine of x divided by 2. So that's a cosine of 1/2 x. Remember that, just the coefficient here is 1/2. So what function, if I take its derivative, gives me cosine? That's the sine function. So the sine of x over 2. Then I got divide by 1/2. Divided by 1/2 is the same as multiplying by 2. So you get 2 times the sine of x over 2 plus your constant of integration, capital C. I can quickly check that's derivative and see it's also cosine of x over 2, which is what I wanted.